Hey everyone! Welcome back to another exciting session with DG Tutorial. Are you preparing for your math exam and feeling a bit shaky about polynomial division and the remainder theorem? Maybe you're finding it a bit overwhelming or just need a little extra help to get it all to click. Don't worry, I've got you covered. We're going to break it down step by step so you can understand it easily. Let's break it down together, and you'll be acing this in no time. First up, the basics. Understanding the fundamentals is key to mastering polynomial division. When we talk about polynomial division, it's similar to regular number division. You have the same components, just with variables involved. You've got your quotient, which is the answer to the division. This is what you get after dividing the polynomial. The dividend is the polynomial you're dividing into. Think of it as the number you're breaking down. The divisor is what you're dividing by. It's the polynomial that does the dividing. And the remainder is what's left over after the division. It's the part that doesn't evenly divide. Easy, right? Once you get these terms down, the rest becomes much simpler. Now, to divide polynomials, we use long division. This method is very similar to the long division you learned in elementary school.
We have 23 divided into 125. We will start with the number on the furthest left. So we first try to figure out, can we divide 23 into 1? The answer is no. So we said 23 into 1 is 0. 0 times 23 is equal to 0. So the answer is 1 minus 0, 1. So we bring down the 25. But before we get to that point, we're going to put 2 first. Then we say 23 into 12. The answer is 0 again. So 23 multiplied by 0 is 0. So then we're going to subtract 0 from 12, which will be 12. Then we're going to bring the 5 down. And now we're going to say 23 divided into 125. And the answer is 5. And 5 times 23 is actually not quite 125. It's actually 115. So now we're going to subtract 115, and the remainder is 10. So we can identify that this 5 is considered the quotient. This 125 is considered the dividend. And the 10 is considered the remainder. While the 23 over here is considered the divisor. And what does this have to do with anything? So what we're going to do, we're going to use the same approach to divide a binomial into a polynomial. So let's get to that point.
Just like dividing numbers, but with variables. It might look a bit more complex, but the process is fundamentally the same. Imagine dividing a binomial into a polynomial. It's like breaking down a larger problem into smaller, more manageable pieces. Your divisor is d, the quotient is q, the dividend is p, and the remainder is r.
So let's look at x minus 2 divided by 4x cubed minus 3x squared plus 2x minus 7. So the first thing we're going to do is try to figure out x minus 2 into 4x cubed only. So we know that x minus 2 into 4x cubed will take us to 4x squared. And then now we're going to multiply the quotient by the divisor. So we say 4x squared times x is 4x cubed. And then 4x squared times 2, which is -2, that will be equal to -8x squared. And we're going to do the subtraction. So 4x cubed minus 4x cubed is 0. -3x squared minus 8x squared. This becomes a plus because we're minusing twice. So this becomes a plus. So now it's really saying 8x squared minus 3x, which will become 5x. So it'll be plus 5x squared. And we're simply going to bring this down. So we're going to bring down 2x. And then we're going to bring down the -7. So now we have 5x squared minus 2x. So again, we're going to say x into 5x squared will be equal to 5x only. So plus 5x. And we're going to multiply it out. 5x times, and 5x is the quotient. So 5x times x minus 2 will be equal to minus, so we're going to subtract it eventually. I'm just putting that there for now. So we're going to have minus 5x squared. And then we're going to multiply -2 times 5x is equal to -10x. Okay, I should put the bracket so we don't get confused. So the bracket should be there, right? And so that would be 10x. Now we're going to subtract. So this would be 0. And this will become 10 plus 2 because the negative on the outside here with the negative on the inside makes it a positive. So we're basically going to have 12x. And we're going to bring down the 7, -7. So now we're factoring. So now we're going to say x into this portion. And of course, that's what we have been doing as we went along. X into 12x will just be 12. And now we're going to do the multiplying across. Okay, so we're going that way, cross multiplying with the divisor. So we say 12x again. And then we're going to multiply -2 times 12 is equal to -24. And of course, we're going to subtract all that's in the bracket. This is going to become 0. And 24 positive minus 7 will be equal to 17. So now this will be our remainder. And this would have been the dividend. And we know this is our quotient, the full quotient. So the quotient will be 4x squared plus 5x plus 12. And we know that this will be our divisor. Okay. And as we said in the previous part of our video, that the divisor is denoted by a D. So where you see a D, that would be the divisor. The quotient is denoted by a Q. So you'll see that as we go through. The dividend is denoted by a P. and the remainder is denoted by an R. So let's look at another example. So we have X plus 6 divided by X squared plus 8X plus 15. This one is easier. And if you follow the example, it will get easier as you go along. So X plus 6, X into X squared will be X, right? And then X times X is X squared. X times 6 is equal to plus 6. And then we're going to subtract that. So we're going to have the 0 here. And then this will be plus 2x. We're just going to bring the 15 down. Then we're going to divide into here, okay? So now we said x into 2x, that's just simply going to be 2. Then we're going to multiply throughout. 2 times x is 2x. And then 2 times 6 is 12. So now we're going to subtract these numbers. We're going to have 0 here. And then that remainder going to be 3. So that will be our answer. Now, when we're doing this kind of question, we would write, another way to write that P is equal to D times Q times R, which is actually the same as X squared plus 8x plus 15. It's actually equal to x plus 6 times x plus 2. And if you thought that the 3 would be added, you're correct. So we do these two. So we have the divisor, right? The divisor times the quotient. And then we add the remainder. And that's why P, which is the actual dividend, is equal to divisor times quotient times R. And this is what we have here. Let's try another one. X plus 7. And this is divided into x squared plus 0x. And I'm going to explain what the question looks like before we get to that point. So originally, the question would have been written, divide x squared minus 49 by x plus 7. And because there's something missing between x squared and negative 49, we had to put a filler there, which had to be a coefficient of x only because we already have x squared over here on the left. So now we're going to do the dividing. So x into x squared is going to be x. And we know x times square x is equal to x squared. And now we're going to be left with 7x. But we also know that because this is a subtraction, this is going to become negative 7x. I'm going to bring down the negative 49 here, and we're going to divide. So 7 into x into 7x. So x into 7x is going to automatically be negative 7. And negative 7. So we're going to say negative 7 times x is negative 7x. And negative 7 times 7 is going to be minus 49, right? Because a negative times a positive is a negative. And so we're subtracting, and we're going to see what happens here. So the remainder is going to be 0. I mean, I didn't have to do it that way, but that was just to make it very clear. So we could write it another way to say P is equal to D times Q times R, whereby x squared minus 49 is actually equal to x plus 7 times x minus 7 plus 0. And we can also agree that the remainder is 0. Which means that the divisor went evenly into the dividend, and the quotient is the factor of the dividend. So that's another thing to think about in this case.
But wait, there's more to it. There's an even faster way to do this when dividing by a binomial of the form x, r. It's called synthetic division. This method can save you a lot of time. Let's run through the steps. It's simpler than it sounds, and once you get the hang of it, you'll find it incredibly useful. Step 1. Write down the coefficients of your polynomial in descending order. This sets up the problem for easy manipulation. Make sure to include a 0 for any missing terms. This ensures that all terms are accounted for even if they have a coefficient of 0. Step 2. Divide by r. This is the value that makes the binomial 0. Step 3. Bring down the first coefficient. This starts the process of synthetic division. Step 4. Multiply it by r and add the product to the next coefficient. This step is repeated for each coefficient. Step 5. Repeat the process until you've gone through all the coefficients. This systematic approach simplifies the division. Step 6. The last term you get is your remainder. See? Fast and straightforward. Synthetic division is a real time saver.
So the first step is to, and this is called, let's just first say what it is. It's called the synthetic division. Then I'm going to get into that shortly. So what is it? It's when you speed up a division of a polynomial by a binomial of type x minus r using coefficients of the variable. So first we're going to put step 1, you're going to write the coefficients. And they must be in descending order. So I'll just put descending order. The second step is to give the missing term a coefficient of 0. So give the missing term so I'm going to give it coefficient. 0. So the next term or step, we're going to divide by r. So divide by r. Step 4, bring down the first coefficient. Step 5, multiply it by r, and then we're going to add the product to the second coefficient. Number 6, repeat the process. And number 7, the last term is the remainder. We know that. Okay? And that's how we do the synthetic division. Now, I'm going to do an example of that. So here we have the synthetic division, and this will be explained. I do have some items on the screen, but I will explain them as I go along. So first we want to, this is the shortcut to provide the factor, which is the divisor. Using the divisor, x minus r, in this case, we have x minus 2. So r is equal to 2. So this is the representative of what we're looking for in order to find the divisor. And we know that this is our dividend. And the question was, what is our quotient when we divide 4x cubed plus 2x squared minus x plus 3 by x minus 2. So we're going to show you the process of doing this. So we have to bring down all the numbers. The first thing we're going to do, we're copying the coefficient. This is what we're doing here. And we're bringing everything down. And then we're going to show you the fastest way to do this. So 2 is the number that we're factoring everything by. So the first example is that we know that 4 is a given, 2 is the coefficient here, -1 is a coefficient here, and 3 is the constant, which we keep. And so we're going to fill in the numbers. You're going to see how the numbers are generated. So the first thing, because 4 does not have anything prior, there's nothing here. There's nothing. So I'm just going to put n. There's nothing here before the 4. So the 4 will just be carried down as it is. So that's what we do here. So then we're going to take the multiplier 2, we're going to multiply it by 4, and then that's going to be equal to 8. So then we're going to get 10. Then we're going to take the same multiplier 2 times 10, and we're going to put that here, which is 20. Then we're going to take 2, and we're going to multiply by the answer, which would have been 19. Okay, and then we're going to put it here, which will be 38. Okay, and as you can see, we're adding as we go along. So first we multiply, then we fill in the spaces. So 2 times 4 is 8, and we multiply the 4 here. 2 times 4 is 8, then we had 8 and 2 make 10. So that's why we have the 10 here. Then we added 2 times 10, which is the sum. That's equal to 20. So the 20 is crossed over to the under the -1. Then we said 20 minus 1 is equal to 19. So that 19 now is going to be multiplied by the 2, the multiplier, which is the r. And then 2 times 19 is 38. Then we add the 38 and the 3, and we get 41. So what that does is it provides all the coefficients and the constants and the remainder for the answer. So here we just need to fill in. So 4x squared plus 10x plus 19 plus 41. And 41 is the remainder. And that would be the quotient.
Now let's talk about the remainder theorem. This theorem is a powerful tool in polynomial algebra. It's a nifty tool that makes evaluating polynomials for specific values super easy. Here's the deal, it simplifies the process significantly. If you divide a polynomial px by xc and your remainder is r, then r equals pc. Simple as that. This means you can find the value of the polynomial at c without doing the full division. So, if you want to find the value of a polynomial at a given point, you don't need to go through the whole division process. Just use the remainder theorem.
The remainder theorem. The remainder theorem is very similar. And in this case, the divisor is equal to x minus c. So before we had r, so we have c. The remainder x is constant. And if that's so, then PC, where C is the divisor, is also constant. So we're going to use the remainder theorem to find P2, and we know that 2 would likely be the remainder, the C, and the C is denoted by the expression px, where x squared or x cubed plus 6x squared minus x minus 27. So we're going to do similar to what we did for the other question, using the synthetic division. We're going to find the coefficients, and 2 is the divisor. So we're going to have 1, 6, -1, and negative 27. So we're going to use the same principle. So again, coefficient of negative x, and then the constant. So we know that we're not going to have anything here because there's nothing previously multiplied, so 1 will be brought down. So now we can say 2 times 1 is 2. So we're going to bring that here. Then we're going to add these two, and we're going to get 8. And then we're going to say 2 times 8 is equal to 16. And then we add these two, we're going to get 15, right? Positive 15. And then we're going to say 2 times 15 is 30. And then 30, and we know the last one must be a remainder, so we always put that line down. And then we say that will be 3, because we know positive 30 minus 27. So what do we have here? Based on the remainder theorem, we only need to find what P2 is. That will be equal to 3. And this is the 3 that we're looking for. And if we want to do a check, there's a way to check it. So Px, where x is cube plus 6x squared minus x minus 27. If we substitute 2 for each of these items, we're going to get 2 cubed plus 6, 2 squared minus 2 minus 27. And the answer must be 3. So for all questions that relate to this principle, the remainder theorem, you are able to check it back to see if you get your answer. And once you follow the same principle here, which is the remainder theorem, I call it RT, then you should find the 3, which is always the number at the end. And it makes sense because when you do the other parts of the formula, you bring down the remainder, or you add, then you multiply using the C, the constant, which is PC, then you will get the remainder 3. And that's it for our lesson.
All right, let's recap everything we've covered. Polynomial division is just like regular division, but with variables. Understanding the terms and steps is crucial. You can use long division or the faster synthetic division. Both methods have their place, but synthetic division is great for quick calculations. And the remainder theorem helps you evaluate polynomials quickly and efficiently. It's a fantastic shortcut, got it? Awesome, you've got this. With these tools, polynomial division will be a breeze. Now get back to your study session and ace that math exam. Good luck. Remember, practice makes perfect. Thanks for watching, and don't forget to like, subscribe, and hit the bell for more math tips. See you next time. Keep practicing and stay confident.